Just keep it from the beginning. So ionic bond, metal and non-metal, noble gas configuration. It is stable. This is full outer shell electrons. We said that the metals lose electrons while the non-metals gain electrons. The metals group 1 lose 1, group 2 lose 2, group 3 lose 3. So this becomes +1 because the number of protons now is more than the number of electrons by 1. And here by 2, so it is +2. And here, for example, aluminum, it is +3. But what happens to the non-metals? They gain electrons. So this will become 3 minus, this will become 2 minus, this will become 1 minus. Here in the, if two non-metals meet, they cannot gain and lose electrons. Because, for example, hydrogen and hydrogen, every one of them has how many electrons? Just 1 electron. It cannot lose this electron. If it loses this electron, it will become 0. And it cannot gain an electron from the other one, because if it gained electron and become 2 like the neon, it will be okay, but the other one is 0. So they have to agree about another idea better than gaining and losing. They cannot make ionic bond. They will agree that they will share 2 electrons. What does it mean? So the electrons will be here for a while, and then here for a while, here for a while, and here for a while. Is it gained or lost? No. It is what? Shared between them. So we will get what's called, everyone will feel like it has 2. It doesn't really have 2, it has only 1, but it feels like it has 2 electrons. And the other also will feel like it has 2 electrons. So it will feel like it is like neon. So it will feel like that it is having the same electronic configuration and it is stable like neon. So there is no loss and gain. There is what? Sharing of the electrons. How many electrons are shared exactly? 1 from each atom, right? So 1 is shared from here and 1 is shared from here. So how many electrons are shared? 2. 1 from each side. We'll say like that. 1 from each side. So how many bonds they are making? They are making only 1 bond. What is the name of this bond? It's called a covalent bond. So it's called a covalent. The covalent bond is sharing of 2 electrons by 2 nonmetals, 1 from each atom, 1 from this atom and 1 from this atom. This made 1 covalent bond. We can draw it as 2 electrons shared in between them, or we can draw it as a single line. What does a single line represent? How many bonds? 1 bond only. So 1 from here and 1 from here. So 1 from each side, or 1 from each atom. Now everyone feels like it has 2. This can happen in other atoms. So this can happen in other atoms. For example, if you are sharing electrons between chlorine and chlorine. So let's see, this is chlorine atom and this is chlorine atom. How many electrons are there in the chlorine atom? Mr. Chlorine has 17 and 35.5 or 35 here. So it has 17 electrons. But Mr., you are never drawing the 17 electrons. You always draw the electrons in the outermost shell only. So you draw only the electrons in the outermost shell. How many electrons in the outermost shell? There is 2, and then it's 8, then 7. So always draw the 7. I'll draw it like that. 1, 2, 3, 4, 5, 6, 7 electrons. So there are 7 electrons. And on the other side, 1, 2, 3, 4, 5, 6, 7. Where is the rest? You don't draw the inner electrons. You only draw the electrons which are in the outermost shell, which are 7 electrons. Mr., if this one gains an electron, it will become 8. And this one, if it gains electron, it will become 6. So this is not a good agreement. You cannot lose and gain. But what about the electrons moving on the other way from here to here? This will be 8, and this is 6. Also not good. So the only answer for that is the covalent bond. Why it is good? Because they will share. How many electrons they will share? Just 1. So put 1 electron from the 7 here and 1 electron from the 7 here. So now let's try to count how many everyone feels like it has. This chlorine atom, it feels like it has 8. It actually has 7 only. 1, 2, 3, 4, 5, 6, 7 ones. But in fact, it will feel like it has 8. So now it will be stable or not? Yes, it will be stable. Why it will be stable? Because it feels like 8. But what's good about feeling like 8? It will be like the next noble gas. The next noble gas after chlorine is argon. It has 18. So it will feel like it has 18 like it. And the other one will be the same. So every one of them, in fact, has only 7 electrons in the outermost shell, but feels like it has 18. So it becomes stable. Again, we will draw the electrons in between like that, or we can draw it like that. 1 chlorine, 1 chlorine, and 1 line. How many electrons every line represent? The line represents 1 bond. And 1 bond means how many electrons? It means 1 electron from each side. Total 2 electrons. 1 electron from each side. So total 2 electrons. Okay. So in ionic bonding, it was very easy to determine how many will be gained or lost. So for example, I have 2, 8, 1. Then I will lose 1. 2, 8, 3. Then I will lose 3. Now 2 and 5. I will gain 3. So it will become 2, 8. 2 and 7. I will gain 1. So it will become 2 and 8. What about the covalent? How do you know how many should be shared? Actually, it is the same thing. You still need 8. You still need 8 electrons, except for the hydrogen. The hydrogen is the only exception, right? You have only 1. You have only already 1. And you need to become like helium. So you need to be 2. The only one that needs to be 2 is as helium is the hydrogen. The rest, all of them needs to be 8. So if you have 1 and you need to be 2, how many you will share? You will share 1. The rest of them, they need to become 8. They need to become 8 as the next noble gas. Take care. 8 means the outermost shell. So how do you know how many electrons I need to share? I will give you a very nice trick. They are always noble gases, right? They are always noble gases configuration, and they are always non-metals. So we will never do this. We will never do covalent bonding with a metal. Take care. We will never mention a metal. Metal only in the ionic. So we will only use the non-metals. So let's see the non-metals. Let's imagine we have nitrogen, for example. Nitrogen has how many electrons? The nitrogen has 7 electrons. So we said we don't use all of them. We don't use all of them. We use only the outermost 5. You want to be like 8. So how many electrons do you need? You need 3. So how many bonds you will make? You will make 3 bonds. Or to be more specific, 3 covalent bonds. But what about oxygen? Oxygen has 8 electrons. So this one has 7, this one has 8. So 2 and 7. You want to become, 2 and 6. 2 and 6. So you want to become 2 and 8. How many is missing? Now missing 2. So how many bonds you will make? 2 covalent bonds. Okay, what about chlorine? We answered chlorine already. We answered chlorine already. Chlorine is, or fluorine is 9. So 2 and 7. Again, you want to become 2 and 8. So how many missing? 1. So you will make 1 covalent bond. So the number of covalent bonds that you make depends on how many missing to become noble gas. If you miss 3, you will make 3 bonds. So for example, our example is chlorine. It was 7. So you need 1, so you make only 1 bond. Again, what about oxygen? We said oxygen is 8. So oxygen is what? Oxygen is 8. So it is 2 and 6. How many you are missing? You miss 2. So how many you will share? You will share 2. So in the outermost shell, you have 6 electrons. But you will not use them all for sharing. You will use how many of them? 2 electrons. How did you know, mister? 6 to 8, you need to share 2. If you are missing 1, you will share 1. If you are missing 2, you will share 2. If you are missing 3, you will share 3. So out of the 6 electrons, let's see the 6 electrons. 1, 2, 3, 4. Don't use all the 6. Use only 2 of them, and 2 you will share. So there are 6 in the outermost. You will share 2, 1 and 1. What about the other atom of the oxygen? You will do the same also. So this is the first atom. Remember, we said oxygen is always diatomic. Diatomic means 2 moves together all the time. So the other oxygen atom. Again, how many atoms in the outermost shell? 6. How many you want them to be? 8. So how many you will share out of the 6? 2. So you have 6. 4 will not be shared. not be shared. It is only for this oxygen atom. They will not be shared with the other one. And 2 will be shared. So everyone shares 2 electrons. Why? Because it needs 2 electrons. Now it is different from the last time. The last time you made 1 bond. We said 1 bond is equal to 1 bond means 1 pair of electrons, which means 2 electrons, 1 from each side. But what about here? How many bonds? Mister, you have 2 pairs of electrons equal to how many electrons? 4 electrons. So 2 from each side. So how many lines you are going to draw? You will draw 2 lines, because every line represents 2 electrons. So total is 4. Total is 4. Let's see the nitrogen. Let's see the nitrogen. Instead of writing it all over again, we'll just copy it and change it. Mister, you said the nitrogen. So let's remove this one and this one and this one. Nitrogen is the same way. It's always diatomic. It's always diatomic. So nitrogen has 7 electrons. It has 7 electrons. How did you know it has 7 electrons? Because it's in group 7. So 2, 6? No, not 2, 6. It's 2 and 5. Mister, it wants to be like 2 and 8. So how many it is missing? It is missing 3. So how many it will share? Every atom will share 3. So every atom will share 3. Why? Because it needs 3. So this nitrogen and this nitrogen, everyone has 5 in the outermost shell. How many it shares out of the 5? Let's draw it from the beginning better. How many it shares? We said every one of them shares 3 because it needs 3. Originally, it had how many in the outermost shell? You don't draw the 7. You only draw the outermost 5. You are sharing 3. So 1, 2, 3, and 2 not shared. They are kept for it. It is its own. So the total is 5. It shares 3 and 2 not shared. On the other side, it shares also 3 and 2 not shared. Why you share 3? Because you need 3. Why there is 2 here? Because that's remaining from the 5. So how many pairs are shared? How many pairs are shared? 3 pairs. Equivalent to how many electrons? 6 electrons. And 3 pairs means how many bonds? 3 bonds. That's why you will draw it like that. Triple bond. So in the chlorine, it shared 1 and made 1 bond. 1 from each side. So the line is like that. 1 electron from here and 1 electron from here. And the oxygen, 2 bonds. 2 electrons from here and 2 from here. And the nitrogen is triple covalent bond. It's called double covalent. So this is called double covalent. And this is called triple covalent bond. Why? Why, Mr. Triple covalent? It's a nitrogen, not oxygen. Because there are 3 lines in between. And this one is called single covalent bond. Single covalent bond. Again, let's summarize the rules that we need to know. The number of electrons that's found in the outermost shell, is the same as the group number, is the same in outer shell, is the same as group number. If you are in group number 5, like nitrogen, you will have 7 electrons, but 5 in the outermost shell. 5 in the outermost shell. If you are in group 6, the number of electrons in the outer shell, it has total 8. But in the outer shell, the same as group number. What's group number? 6. So it has only 6 in the outer shell. And 7. Fluorine has 9 total, but only 2 and 7. So has 7. So the number of electrons in the outermost shell, you can know it automatically by seeing the group number. This is the group number. How many electrons you need to share? The number of electrons to share is the missing electrons. You have 5 in the outermost and you need to be 8, so you share 3. Here you will share 2 from each atom here to become 8, and here you will share 1 from each atom to become 8. Number of electrons to share is the missing number to reach 8. Except for the hydrogen, it's only 1 because it wants to reach 2. To reach the 8, which is of the noble gas configuration. That will be enough. Let's continue to the questions.